Alright class, this is Mr. Stumbaugh. Today we are on chapter 0, lesson 11, talking about probability and odds. Probability is simply the number of favorable outcomes, or the number of outcomes that we're looking for, divided by the total number of possible outcomes. If you see the words equally likely, that means every possibility has the same chance. They all have a 1 in whatever that number is chance. They will all have a 1 in 10 chance. They all have a 1 in 5 chance, a 1 in 6 chance. And that would mean each of them has an equal chance of getting picked. For example, if you have a dice, my pretty blue dice right here. We know that when we roll a dice, we can roll a 1, a 2, a 3, a 4, a 5, or a 6. We also know that each one of those has the same chance of being rolled. So when we look at that, each one of these will have a 1 in 6 chance. Because we have 1, 2, 3, 4, 5, 6 different numbers, and they only appear one time, they each have a 1 in 6 chance of being picked. Now, if a die is rolled, and they are looking for a 1 or a 5, things change a little bit. We know that there are still 6 total outcomes. But now we have not 1 chance, but 2. So we have a 2 in 6 chance of rolling a 1 or a 5. But we are not done. I don't want you to see this. I want you to reduce down to 1/3. So if you think about it, 1 over 5, we have a 2 in 6 chance. We have a 1 in 3 chance when we simplify that fraction. Now, if they said we want to roll an even number, we can roll a 2, a 4, or a 6, and have that be what we want. There are 6 total sides of the dice, and we have 1, 2, 3 outcomes that we want. We reduce this down. We have a 1 in 2 chance of rolling an even number. If they're looking for the complement of a ratio or probability, for example, rolling a 1 versus not rolling a 1, they are complements of each other. And I'll show you why. Rolling 1, we remember we have a 1 in 6 chance. If we do not want to roll a 1, we have a 5 in 6 chance. Because we can roll 2, 3, 4, 5, or 6. To find out if these are complements, we add them together. If they equal 1, they are complements. So the complement of one scenario will always be the rest of the fraction for it to equal 1. So now we have a big bowl of chips, and this is what is inside. We have 5 red chips, 7 blue chips, 6 yellow, and 10 green. To find our total number, we add them up. 5 and 7 is 12. 10 and 6 is 16. We have a total number of 28 chips. Now they want to know, what is the probability of drawing a blue chip? We know there are 7 in there. We know we have 28 total. This needs to be reduced. There is a 1 in 4 chance of you drawing a blue chip from the bowl. This time, they want a red or a yellow chip. We know there are 5 red. We know there are 6 yellow. There are 11 chips in there that we can draw from to be favorable, and 28 total. Does not reduce. 11 over 28 is your answer. Now they want to know the probability of not drawing a green chip. They will take red. They will take blue. They will take yellow, not green. So we know there are 5 red, 6 yellow, and 7 blue. Add them together. 12, 13, 14, 15, 16, 17, 18. There's 18 chips that we can draw to where it's not green. 28 total chips. No, we are not done. Divide each of those numbers by 2. There's a 9 in 14 chance of drawing the chip we want. If you want a percentage, all you have to do is plug this into the calculator. 9 divided by 14 will give you a decimal. The decimal is 0.64. So we move the decimal over 2, and it'll be about 64%. You can do that with any of these. 11 divided by 28, 0.39. Move it over, 39%. Now we have different options to choose from. They have baseball caps in blue, yellow, and in white. We also know that it can come in the logo or the initials. If you draw it out like this, the easiest thing to do is to make a giant box and divide it across. All you have to do, blue cap with the logo, yellow cap with the logo, white cap with the logo. Blue cap with the initials, yellow cap with the initials, white cap with the initials. A simpler way to do this, we have 1, 2, 3 options over here, and 1, 2 options over here. We take the number of options we have on each side and multiply them together. We have 6, which matches the number of boxes that we have made. So now we want to get some ice cream. But we have options. We can get it in 1 scoop, 2 scoop, or 3 scoops. There's 12 flavors to choose from. And we can either get it in a waffle cone, a sugar cone, or a cup. It is very difficult to make a box that is 3D because we have all these different options. If you want to make yourself a 3D box for every problem, more power to you. But there's a lot easier way to do this. We have 1, 2, 3 options here. We know we have 12 options here. We have 1, 2, 3 options here. All we're going to do is multiply those together. Bring it over here. 3 times 3 times 12. There are 108 different options. You can get 2 scoops with flavor number 4 in a waffle cone. You can get 3 scoops, flavor number 6 in a cup. There are 108 different options to go by. Now let's say we need to use a 3-digit password for a website. We're going to use the numbers 0 to 9, but once we use a number, we cannot use it again. That prevents us from going 111 as our password, or 122 as our password. None of these numbers can repeat. How we figure out how many different options we have is from 0 to 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 10 options for our first number. But we are going to use one of these numbers. Let's say we want to use 4. We cannot use 4 the rest of the time. So for our next number, we only have 1, 2, 3, 4, 5, 6, 7, 8, 9 options. Well, this time we want to use the number 7. We cannot use 4 or 7 anymore. So now we have 1, 2, 3, 4, 5, 6, 7, 8 options for our third number. 10 options for the first number, 9 for the second, 8 for the third. How we figure out how many options we have, we simply multiply them together. 9 times 8, 72. 72 times 10. There are 720 different combinations that you can use to make your password. Now, when they want to know the odds, all we're doing, like if we take the dice, for example, we remember there's a 1 in 6 chance of rolling one of the numbers. When they want odds, they want you to write it like this. 1 to 6, 1:6. They don't want it like this. They want it like this. So when you see odds, make sure you do 1 to 6. If it's 2 to 6, that is not right. They want it reduced as much as possible. Probability and odds can be very simple as long as you can remember this. The number of outcomes we're looking for divided by the total number will get you your ratio. Plug it in a calculator, move the decimal, and you got your percent. That's pretty much all they want you to know for this chapter.